Imagine you're trying to explain where your house is to a friend, but you can only draw it on a piece of paper. That drawing is a kind of map. A map is essentially a flat model of a real place, whether it's your neighborhood or the entire planet. Because the world is so huge, cartographers, that's what we call map makers, use special tools and rules to shrink it down accurately. The cool thing about maps is that they give us a quick way to see a big picture. They show us not just where things are, but also how far apart they are and the path we need to take to get there. Maps are powerful tools that connect us to the world and help us find our way, which is why learning map basics is the first step to becoming a true explorer. Have you ever played the game Battleship? You need a coordinate, like B5, to find the enemy ship. Maps use a similar idea called a grid system to locate everything. This grid is made up of imaginary lines crisscrossing the globe, kind of like graph paper. When these lines cross, they create a unique address for every single point on Earth. This is called the absolute location, the exact spot, no ifs, ands, or buts. Without this grid, trying to find a place like the Statue of Liberty would be like trying to find a single grain of sand on a huge beach. Let's look at the first set of imaginary lines, latitude. Think of latitude lines as the flat, parallel rungs of a ladder circling the globe. They run horizontally from east to west, but they measure how far you are to the north or south. A fun way to remember them is that lat is flat. These lines never cross, so we call them parallels. As you move from the middle of the Earth toward the North Pole or South Pole, the degrees of latitude increase. They are the first number in any set of map coordinates. The most important line of latitude is the equator. Imagine a giant belt cinching the Earth right in the middle. That's the equator, and it's assigned 0-degree latitude. It's the starting line for measuring north and south. The equator does more than just give us a starting point. It actually divides the world into two equal halves. Everything above the equator is in the northern hemisphere, and everything below it is in the southern hemisphere. The climate near the equator is usually much warmer because it gets direct sunlight year-round. Now, let's look at the other set of lines, longitude. These lines are different. They run vertically from the North Pole to the South Pole. They measure how far you are to the east or west. We also call these lines meridians. Unlike latitude lines, meridians are not parallel. They are farthest apart at the equator and then come closer together until they all meet at the North and South Poles. They look like the wedges of an orange peel. Just as the equator is the main line for latitude, the prime meridian is the main line for longitude. It's 0-degree longitude, and it runs through a place called Greenwich, England. This line is our starting point for measuring east and west. The prime meridian, along with the international date line on the opposite side of the globe, divides the world into the eastern hemisphere and the western hemisphere. The US is almost entirely in the western hemisphere. The prime meridian is also super important for calculating time zones around the world. So, how do we use latitude and longitude together? When you put the two measurements together, they form a set of coordinates, which is the absolute location. Think of it as your Earth address. For example, if you say a place is at 40-degree north, 100-degree west, that tells someone the exact spot on the globe. A key rule for map coordinates is that you always say the latitude, north or south, first, then the longitude, east or west. This system is used by pilots, ship captains, and even your smartphone's GPS to pinpoint locations with incredible accuracy. Before latitude and longitude, people had to rely on basic directions for travel. The most fundamental ones are the cardinal directions, north, south, east, and west. These are like the building blocks of navigation. We can remember them easily by observing where the sun rises, east, and sets, west, or by using the North Star to find north. Learning these 4 directions is crucial because almost all other directions are based on them. If you know north, you know everything else. Sometimes, just saying I'm going north isn't specific enough. What if you're traveling between north and east? That's where the intermediate directions come in. These directions, northeast, southeast, southwest, and northwest, help us give much more accurate instructions. If you're on a hiking trail, for example, knowing to head northwest instead of just north could be the difference between reaching your destination and getting lost. They make navigating a real landscape much easier. How do we know which direction is which on a map? We look for a little symbol called the compass rose. This is a small drawing on the map that shows the orientation of the cardinal directions, and sometimes the intermediate ones too. The compass rose almost always points out where north is. Sometimes it's just a simple arrow with an N. This small symbol is your key to reading the map correctly. You always want to line up the map with the real world's north before you start following directions. While the compass rose shows direction on a map, a magnetic compass shows direction in the real world. This simple tool has a magnetic needle that is attracted to the Earth's magnetic North Pole, so the red end of the needle always points north. When you use a compass, you are able to correctly align your map. You turn the map until the map's north arrow matches the compass needle. Once the map is oriented, the directions on the map, left, right, ahead, will match the directions in front of you. Think about taking a picture of a huge football stadium and shrinking it down to fit on a postcard. You can still see all the parts of the stadium, but they're much smaller. That's what a map scale is. It tells you how much the real world has been shrunk down to fit on the map. The scale is critical because it allows you to calculate the actual distance between 2 points. If a map didn't have a scale, you wouldn't know if the distance between 2 cities was 10 miles or 1,000 miles. Cartographers use 3 main ways to tell you what the scale is. The easiest is the verbal scale, which is just a sentence, like 1 inch equals 10 miles. Then there's the ratio or representative fraction scale, which looks like a fraction, such as 1 to 100,000. Finally, you have the graphic or bar scale. This is a small line on the map that looks like a ruler, and it's marked with actual distances like 0 to 50 miles. All 3 methods give you the same information, just in different formats. Let's practice with the verbal scale. If a map says 1 centimeter equals 10 kilometers, it means you can take a ruler and measure the distance between your town and the next town over. If that distance on the map is 5 centimeters, you just multiply 5 times 10 kilometers, which tells you the real-world distance is 50 kilometers. It's straightforward multiplication, turning map inches, or centimeters, into real miles or kilometers. The ratio scale looks a bit more complicated, but it's very useful for consistency. A scale of 1 to 100,000 means 1 unit of measurement on the map represents 100,000 of the same units in reality. The great thing about the ratio scale is that it works no matter where you are in the world. If you're using inches, it's 1 inch to 100,000 inches. If you use centimeters, it's 1 centimeter to 100,000 centimeters. You don't have to worry about converting between different types of units. When we talk about map scale, the terms large and small can be a little confusing. A large-scale map is one where the fraction is large, meaning the area you are looking at is small, but the details are huge. Think of a map of a single city block. A small-scale map shows a huge area, like the whole continent, but the details are tiny. The fraction is small, so remember, large scale means large detail but a small area, and small scale means small detail but a large area. Here's a big problem map makers face. The Earth is round, but a map is flat. Try peeling an orange and laying the peel flat. It tears and stretches, right? That stretching on maps is called distortion. Because of distortion, things on a flat map don't look exactly the way they do on a globe. Areas near the poles, like Greenland and Antarctica, often look much bigger than they are in real life. That's why we use different kinds of map projections, each one trying to reduce the distortion for a specific purpose. Maps are full of different colors, symbols, and lines that all mean something. You can't understand a map unless you can read its secret code. That code is found in the map key, which is also called the legend. The key tells you what every little symbol on the map stands for. A thick line might mean a major highway, a thin blue line is a river, and a tiny airplane symbol marks an airport. Always check the legend first, or you might end up driving into a lake. We've learned 2 ways to describe location. Absolute location is the exact, unchangeable address using those latitude and longitude coordinates, like 34 degree north, 118 degree west for Los Angeles. It never changes. Relative location, on the other hand, describes a place by relating it to other places. You might say, Los Angeles is south of San Francisco. Relative location is super helpful for giving basic directions, but absolute location is what pilots and GPS systems need for precise navigation. To wrap up, maps are our windows to the world. They rely on just a few basic elements to help us understand everything. Latitude and longitude form the grid for absolute location, giving everything an exact address on Earth. The compass rose and other direction tools show us which way to go. And finally, the map scale is the essential tool for turning small measurements on paper into massive real-world distances. Master these 4 basics: latitude, longitude, direction, and scale, and you'll be able to navigate and understand any map you come across. Keep exploring.